Okay, I'm going to give the solutions to the tutorial questions. Where are the others? I only have 8 now. The rest.
I asked them to come back in the WhatsApp group.
Okay. Basically, most only that they want to save their data, so they get out first.
Yes, it is.
Yeah. Okay, let ask them to join so that we can start to what do you call it? To get the solution. Okay. I'm going to share the solutions. Okay, everybody can see this?
Yes, sir.
Okay. So basically, this is the first question, right?
Yes, sir.
Okay. You are given a circuit, and wait. Okay. Let me see. Wait, so you are given the circuit. The circuit, you have 4 amps. You have a 3 ohm resistor, 1 ohm resistor, 2 ohm resistor, 1 ohm resistor, and 1 ohm resistor. So you need to find the V1 and V2. And from here, you are going to use the nodal analysis. Okay?
Okay.
Oh, okay.
So for nodal analysis, basically that from here, you recognize that you have how many nodes? 1 node, 2 nodes, and 3 nodes, right?
No.
This
Yes, sir.
node you set as reference node. Okay. Now, from here, we need to write the equation. When we use a nodal analysis, then we need to write the KCL, Kirchhoff current law, where it says that the current entering a node, the summation of the current entering the node is equal to the summation of the current leaving the node. So for V1 node, we have 4 amps entering the node. Let me see. I need to use the highlighter. I need to use the highlighter. Okay. Okay. So basically that too big lah. How am I going to? So this current entering the node 4 amps, and current leaving the node, which is through this 1 amp and this 1 amp. So we can write the equation you can write the equation wait. I don't need to write. Is text. I don't want text. Okay. So we can write this equation, right? These box are difficult. I want to use. So the first one is V1 minus 0 divided by 3. So this, right? So this equation, right? V1 over 3. The second one is V1 minus V2 divided by 1. So you have most probably that I need to use the through the what call it different tools. So basically that you have a current flowing from V1 to V2, this one. So V1 minus V2 over 1. And this is the current going in. So in this example, we have the convention is that going in is minus, going out is positive. It's a plus. So we have V1 over 3 plus V1 minus V2 over 1 minus 4 equal to 0. So there is one equation for node 1. So at node 2, you have current basically that flowing from here flowing into V2, and you have current flowing out from V2 through this one and through this one. So then we can write, so V2 minus 0 over 2, this is this, plus V2 minus 0 over 2, because 1 plus 1, this is in series. So equal to 2. So V2 over 2. And this is going in. So actually minus V1 minus V2 over 1. So we can write V2 minus V1 over 1. So this is another equation. So you have these two equations, okay, for V1 and V2. Then we rearrange the equation. The first one, when we arrange the equation, basically that we have V1 over 3 plus V1 minus V2 minus 4 equal to 0. So we got 4 over 3 V1 minus V2 equal to 4. And the second equation that we have V2 over V2 plus V2 over V2 plus V2 minus V1 equal to 0. This rearranged to become minus V1 plus 2 V2 equal to 0. So from here, we solve this simultaneous equation. So you get V1 equal to 4.8 volts and V2 equal to 2.4 volts. Clear? So
Clear.
everybody,
Clear,
everybody clear? Clear? Everybody clear?
Clear. Clear.
Okay.
Yes, sir.
That is the first solution. Who got this right? Among all of you. Who got this right? Huh?
One.
I couldn't hear you.
Jawapan betul tapi jalan kira dia lain.
Jalan kira dia lain macam mana? You use nodal analysis or what?
Oh, saya tak guna nodal analysis.
The question asks you to find the nodal using the nodal analysis. Okay.
Alright, sir.
So because normally when it's given V1 and V2 like this is actually in nodal analysis. Okay.
Okay, sir.
That is number one. Number two, You are given these circuits and you are asking to solve for I. Okay, this I. And I think this one I already solved in the lecture, right? So from here, you can find, you can, what do you call it, how many nodes that you can find?
3.
How many nodes?
3 notes.
3, sir.
Are you sure?
Yes.
Huh?
Yes, sir.
Yes.
Empat.
I think it's 4.
Yeah, 4.
4, sir.
I think it's 4.
1, 2, 3, 4, sir. 4.
Ah, okay. So you have this one, this one, this one, and this one. Okay, you have 4 nodes, and this one you set as reference node, as a ground. Okay, so you have n-1 equation. So at node 1, we call this at node 1. Then we can write, what is the equation? 2 is going out, and this one is, we can write as all going out, going out from the node. So we have, this is V1 minus V2 divided by 0, wait, divided by 0.5 plus V1 minus V3. This is V3, okay? This is V1 minus V2. Basically, you can put the sign here, V1, V2, and V3. So V1 minus V2 over 0.5 or 0.5. V1 minus V3 over 0.5 and minus 2m equal to 0, or V1 minus V2 divided by 0.5 plus V1 minus V3 divided by 0.5 equal to minus 2. Okay, so this is the equation for node 1. For node 2, this node, you have also, we consider, we have, this one is going to the node, the current going to the node, and this one is going out to the node, and going out to the node. So the first one is, since the convention for this textbook, they use that going in is minus and going out is plus. So therefore, this is actually minus V1 minus V2 over 0.5. Basically, can be written as V2 minus V1 over 0.5 plus V2 over 0.25 and plus I equal to 0. So that is the node 2. For node 3, then you have, this is going in, which is minus, this going out, and this going in. This is going in minus, this going out is plus. So we can write V3 over 0.33 minus I, this, and minus V1 over V1 minus V3 over 0.5, or you can write V3 minus V1 over 0.5. So the third equation is V3 minus V1 over 0.5 plus V3 over 0.33 minus I equal to 0. And we know that V3 is equal to V2 plus 3. This is where how do we know that? It's actually from this. This is V3, this is V2. So V3 is actually V2 plus 3 volts. Okay. So this is that. Now we can eliminate either V2 or V3 from the equation, and be left with 3 equations with 3 unknowns. So we substitute into the equation, which is we substitute V3 with V2 plus 3. Yeah. So we get this. V1 minus V2 divided by 0.5 plus V1 minus V3 minus V2 plus 3 over 0.5 equal to minus 2. And V2 minus V1 over 0.5 plus V2 over 0.25 plus I equal to 0. And V2 plus 3 minus V1 over 0.5 plus V2 plus 3 divided by 0.33 minus I equal to 0. And we solve. Actually, we simplify these 3 equations and we solve the simultaneous equation, and we can find I equal to 8.286 M. Siapa boleh buat? Who got this right? Ada yang dapat? Ada yang dapat? Tak ada. Okay.
Tak ada, sir.
3.5 is actually a mesh analysis. It's a mesh analysis. Okay. So we are given these circuits, and you are given the value of I1, I2, and I3, right? And we need to find the current through the R1, R2, and R3. Okay. This one, we can find the current through the, we can find the KCL at node A here. You can find that. So basically that you have, what is the equation for node A? You have I1, okay, going in. You have I3 is going out. IR1 is going out. So the summation of a current entering a node A is equal to the summation of a current going out from node A. So you have I1 going in equal to I3 plus IR1, or it can be written as minus I1. This is in this convention, this minus is going in, minus I1 plus IR1 plus I3 equal to 0. Okay, so IR1 is equal to I1 minus I3, and I1 and I3 was given in the question, which is in the question was given as I1 is 5, I2 is 3, I3 is 7. So I1 is 5. Minus 7 is equal to minus 2 amps. Dapat? Anybody got that?
Yes, sir.
Okay. This can also be done by inspecting, noting that the assumed direction of the current through IR1 and the direction of I1 are the same. Assumption. Actually, you can know that actually is a minus. It's a different direction. I1 and I3. B. Assume a direction for the current to R2, for example, from node B to node A. So you assume that the current is flowing from node B to node A, right? Okay. Then summing current at node B. So this one actually you write the KCL at a node B. So what is the node B is basically you have this current. This node B, you have I3 going in, I2 going in, I2 is going out, I is going in, and you have R2. And you have IR2 here. So IR2, we assume is going out. E to A. In this example. So you can write the equation. I2 is going out, is positive. Or this one they assume a direction from the current from node B to A. So basically that I2 is going out from B, so positive, and IR2 is going out from node B to node A is positive. So minus going in. So you get this equation, right? So I2 plus IR2 minus I3 is equal to 0. And you substitute the equation. I3 was 7, right? Minus I2. I2 was given as 3. So minus 3 is equal to 4 amps. Right? Then the last one. So only one mesh current flow through R3. If the current through R3 is assumed to flow in the same direction, then IR1 is equal to I3 equal to 7 amps. This one is IR3 ya. Silap dulu. IR3. Okay? R3. Right? Everybody got this?
Yes.
Okay. So the next one is 3.7. Same. There's different circuit. Okay. Actually 3.8 nanti sama. Okay. This one is that you are asked to use a nodal analysis to solve for I1 and I2. Right? So using a nodal analysis, so you have to recognize the node. So node 1, node 2, and reference node. Okay. So at node 1, you have I1 is going out, you have 1 amp is going in, and we assume the current is actually from node 1 to node 2 through R2. So you can write, okay, V1 minus V2, okay, V1 minus V2 divided by R2 is, wait, this one is, okay, wait, this one is actually, wait, for this example, they use 3 is R2, this is R1, this is R2, this is R3. So node 1, okay, let me see which one is indicated as node 1. V2 over 1. Kesilap apa ni? R1. Wait, I need to what call it, okay, this one, okay, 1, okay, and I think the sign is different, R1, R2, R3 ni. E. So actually this is actually the answer given in the solution. So okay, we use our own solution. So let's say V1 here and V2 here and the ground here. Okay, for V1 node 1 we have 1 ohm, 1 amp flowing going in. So this is minus 1 amp plus I1, okay, plus going out. So V1 minus V2 divided by R2. So if we use this R2 is 1, so V1 minus V2 over 1 plus V1 over R1
3.
over 3. So V1 over 3 equal to 0.
One.
Equal to 1. Okay. So node 2 here is basically that we have V2 minus V1 over 1
Plus V2
plus
over
V2
over 6.
over 6. So basically this equation ni ada silap sikit ni, the solution. So this one I will correct using call it our own apa ni solution. I will correct this. So basically that from there you do the what do you call it? You simplify the equation. So you get the answer. So this one I will give a correct answer later. I will correct this one. So basically that from here you find V1 and V2. Then after that you substitute because I1 is actually V1 over 3. So ini. Jadi V1 over 3. And 2 is actually V2 over I2 is actually V2 over 6. So this is the I2. This one is correct, but this one is wrong. This equation not 1 is wrong. So I need to correct this. Okay. So I give you the correct solution later. The same question that you need to solve using the mesh analysis. Okay. For mesh analysis, so basically you have 3 meshes. I1, I2, and IA, IB, IC. So we don't use I1, I2, I3 because what I call it? The indication is that the what we need to find is I1 because I1 in this case is actually IA minus IB. Okay. Nampak tak? I1 is actually IA minus IB. So IA is 1 amp here. This is IA 1 amp. Yeah. Mesh 1 is IA is 1 amp. At mesh 2, this mesh you have 3 times IB minus IA plus IB times 1 ohm plus 6 times IB minus IC equal to 0. Okay. That is the second mesh. The third mesh, IC is equal to 2 amps. Okay. Yes. Clear here. And from this, you substitute IA and IC into this equation, then you got IB, which is 1.5 amps. Then you have IA, IB, and IC. Therefore, you can find the I1 and I2, because I1 is IA minus IB, and I2 is actually IB minus IC. So you get that answer. I1 is minus 0.5 amps, and I2 to minus 0.5 amps. This one I don't give. I miss this one.
Yes, sir.
2.12. I miss this one. Nanti lah. So I skip this. And the last one. So you are given these circuits and assume that this F1, the fuse S1 blows. So basically when this blows, there is no current flowing here. Current is equal to 0, right? So you are given VS1 and VS2 is equal to 115 volt, and the value of the resistance are given. R1 equal to R2 5 ohm, R3 10 ohm, R4 and R5 is 200 milli ohm. So this are very small resistors. Okay. So specify. So what you need to do is that you need to specify the polarity of the voltage. The ground is already given here. So the current through the fuse 1 is 0 because this one is blown. So therefore, we need to write the KCL, actually across the KCL at which point? At this point. Okay. And at this point. So the first one, this. So this is actually just the current through R1 and the current through R3, because the current here is 0. So this node is only you have 2 branches. So therefore, 0 current here plus VR1 minus 0 divided by R1 plus VR1 minus VR2 over R3, because this is actually VR2 is here, because this is 0, the ground. So VR2, so this is VR2. So this is the first equation. The second equation is that we have VR2 minus VS2 divided by R5 plus VR2 minus the ground divided by R2 plus VR2 minus VR1 over R3. So we have 2 equation for node 1 and node 2. From there, you can simplify. You can simplify as follows. So you get VR1 times 1 over R1 plus 1 over R3 plus VR2 times minus 1, 0. And another one with VR1 times minus 1 over R3 plus VR2 times 1 over R5 plus 1 over R2 plus 1 over R3 equal to minus VS2 over R5. And you substitute the value of R3, R1, R2, R3, and R5. You can solve the equation, simultaneous equation. So therefore, you get VR1 is equal to minus 39.39 volts. And VR2 equal to minus 109.2 volts. Okay? Okay. And VR4 is from this equation, right? This is a you use the KVL, you use the mesh analysis, because which mesh? This one mesh and this another mesh. This one there is no current flowing because this open loop, so you discard this one. So you have this. So for this one, basically you have VR1 plus VR3 plus VR2 equal to 0, and another one was VS2 plus VR2 plus VR5 equal to 0. So this equation, So yes, you substitute, because VR1 and VR2 you have. So therefore, from here you can find VR3, the 72.81 volts, and from here you can find the VR4, because VR1 you know VF is 0 because the fuse is considered as 0. VS1 was given, so therefore you can find the R4, right? One macam mana terbalik ni? Di sini terbalik. Okay. Actually VR4, not at the fuse. This is terbalik. Different. Okay. This is the other way around. Not the voltage of the fuse. Okay. Yeah. So I will correct the solution and I will post it to all of you later. Okay.
Alright,
Sir,
Yes.
sir. Saya confuse sikit lah dia punya KCL equation untuk soalan ni. Boleh terang lagi?
KCL.
KCL equation dia.
Wait This one. This.
Yes, sir.
You confuse this one.
Yes, sir.
Which part?
Note 2.
This one. KCL, this one. This is the first node. 0 is this one. This. Okay. This is 0 because fuse 1 is assumed to be open because it's blown. Read the question. The question says that the question says that if F1 now blows or open, determine using KCL and node analysis the new voltage across R1, R3, and R1, R2, and R3. That was the question. So when this is blown, this is open. When this is open, the current is 0. So the current is 0. The next branch, this branch. This is ground. So ground, the voltage is 0. So VR1, this node, minus 0 divided by R1. So this is the one. And VR1 minus VR2 divided by R3. So this is the one. So equal to 0. So that is the KCL for the node, this VR1. For second node, this VR2 node. So the first one is, let's say we take this one. So VR2 minus 0 divided by R2. So this is 1. Plus VR2 minus VR1 divided by R3. So this is the 1. And VR2 minus VS1, VS2 divided by R5. This is the equation. Okay. Maybe this part you scale lah kot. So basically this is actually VR2 minus VS2, or since the polarity is reversed, so it's minus VS2 over R5. Okay, clear?
Yes, sir.
Okay. So that is the solution for the tutorial today. So I will rectify the mistake in the solution, and I will pass it to you later. Okay.
All right. Sir.
Any question? And what I'll do is that from the solution, you can do your revision to check where you make your mistake, and if you still do not understand, then you can ask me tomorrow. Okay.
All right. Sir.
And also, since tomorrow is 1 hour, I'm going to give you the question maybe tonight for you to try, and tomorrow we go through the solution for the superposition, Thevenin, Norton, maximum power transfer. Okay.
Okay, sir.
Any question?
No, sir.
No, sir.
Other question? So I will stop the sharing, and I will now is 12:42. What I will do is that we stop the lecture today, and I will rectify the solution, and I will post the solution in the MS Team for you to go through. Right? And also I will give you the question for the tutorial tomorrow. Okay.
All right.
Thank
sir.
you.
Okay,
All
sir.
right.
All right, thank you, sir.
Okay, thank you.
Okay, sir.
Okay.
Bye.
Okay, sir.
Thank you, sir.
Okay.